Have you ever looked up at the Milky Way on a clear night and felt connected to the cosmos? Those rivers of light stretching across the darkness, millions of stars visible to your naked eye, creating the illusion that space is full, that the universe is crowded with light and life. But that illusion, beautiful as it is, hides a truth so vast it can make you feel dizzy. The distances between galaxies aren't just large, they're incomprehensibly, almost violently empty. The space that separates one island of stars from another is so vast that it challenges our ability to understand what distance even means. Tonight, we drift into that emptiness, into the cosmic voids that dwarf anything our minds evolved to grasp, to ask not just how far apart galaxies are, but what it means to exist in a universe where nearness is an illusion, and isolation is the fundamental state of being. So close your eyes. Let the weight of emptiness settle around you, and follow me into the terrible beauty of cosmic distance. Before we begin, if you're kind enough, a gentle like or a quiet tap on subscribe would mean the world to me. It's a small gesture, but I hold it with deep gratitude, because every bit of your support keeps this tiny universe alive and reminds me that these quiet stories still find their way to gentle hearts like yours. Now, let's begin with the first question. Part 1. How empty is the universe? Really? When you look up at the night sky, you're seeing thousands of stars, each one a sun like ours, burning in the darkness. The Milky Way appears as a luminous band stretching from horizon to horizon, so dense with light it seems solid. But this is an illusion of perspective. You're looking along the plane of our galaxy, through hundreds of billions of stars stacked in layers. What you're not seeing is the space between. According to NASA's Goddard Space Flight Center, our Milky Way galaxy is about 100,000 light-years across. It contains somewhere between 200 and 400 billion stars, along with vast clouds of gas and dust. That sounds crowded, and within a galaxy, relatively speaking, it is. But step back. Look at the space between our galaxy and the next, and everything changes. The nearest major galaxy to us is Andromeda, a spiral galaxy slightly larger than our own. It lies 2.5 million light-years away. Let that distance settle in. 2.5 million light-years. Light, traveling at 186,000 miles per second, takes 2.5 million years to cross the gulf between us. If you could somehow watch Andromeda in real time, you'd be seeing it as it was when our earliest human ancestors were learning to use stone tools. The light entering your eyes tonight left that galaxy before our species even existed. But distance in light years doesn't convey the emptiness. Let's try a different scale. If you shrank the Milky Way down to the size of a dinner plate, about 10 inches across, Andromeda would be another dinner plate, 25 feet away. Everything between them, that entire 25 feet, would be nearly empty. Not completely empty. There are stray atoms, ancient photons, wisps of intergalactic gas, but so diffuse, so sparse, that calling it a vacuum doesn't capture the profound nothingness. ESA's Planck satellite has mapped the universe on the largest scales, revealing how galaxies cluster together in vast filaments and sheets, separated by enormous voids. These cosmic voids, empty regions of space containing almost no galaxies, can stretch for hundreds of millions of light-years. The Boötes void, discovered in 1981, spans 330 million light-years and contains only 60 galaxies in a space where you'd expect to find 2,000. It's a bubble of emptiness so vast that crossing it at the speed of light would take longer than complex life has existed on Earth. Within our own cosmic neighborhood, called the local group, there are about 80 galaxies, but most are dwarfs, small collections of stars gravitationally bound to larger galaxies like the Milky Way and Andromeda. After Andromeda, the next significant galaxy is the Triangulum Galaxy, about 3 million light-years away. Beyond our local group, the distances grow even more staggering. The Virgo cluster, the nearest large collection of galaxies, lies 65 million light-years away. Between us and Virgo stretches a void so vast that if you could cross it at the speed of light, human civilization would rise and fall thousands of times over during your journey. NASA's Hubble Space Telescope has captured images of galaxy clusters billions of light-years away, revealing the cosmic web, the largest known structure in the universe. This web consists of filaments of galaxies connected by threads of dark matter, surrounding vast empty voids. From a distance, the universe looks like foam, with galaxies concentrated on the surfaces of bubbles and nearly nothing in between. But here's what makes these distances truly incomprehensible. It's not just that space between galaxies is empty, it's that it's expanding. According to measurements by ESA's Planck satellite and NASA's Spitzer Space Telescope, the universe is growing at about 70 kilometers per second for every 3.26 million light-years of distance. This means that Andromeda, despite being gravitationally bound to us, is one of the few galaxies not receding. Most galaxies are moving away, carried by the expansion of space itself. For distant galaxies, this expansion dominates. The farther away a galaxy is, the faster it recedes. Galaxies a billion light-years away are moving away at about 21,000 kilometers per second, roughly 7% the speed of light. Galaxies 10 billion light-years away are receding at nearly the speed of light. And beyond a certain distance, they're receding faster than light can travel. Not because they're moving through space, but because space itself is stretching faster than photons can cross it. This creates a chilling realization. The vast majority of galaxies in the universe are moving away from us, and the expansion is accelerating. According to the 2011 Nobel Prize-winning discovery by Saul Perlmutter, Adam Rees, and Brian Schmidt, dark energy is driving this acceleration. In time, distant galaxies will slip beyond our cosmic horizon, their light stretched and redshifted into invisibility. Future civilizations, billions of years from now, might look up at a sky devoid of distant galaxies, unaware that a vast universe once surrounded them. As cosmologist Lawrence Krauss once said, "We live in a universe that is becoming increasingly lonely." The distances between galaxies aren't just large, they're growing. The isolation we feel when contemplating these vast gulfs is a feature of the cosmos, not a bug. Space is fundamentally empty, and it's getting emptier. Take a slow breath. Right now, the nearest major galaxy to us is 2.5 million light-years away, a distance so vast that light from there began its journey before humans existed. And that's the closest one. Most galaxies are billions of light-years distant, separated by voids of such profound emptiness that the space between contains almost nothing at all. And as we sit with this emptiness, another question emerges. If galaxies are so far apart, what would it actually take to travel between them? How long would such a journey last? And what would you encounter along the way? That's where we drift next. Part 2. What would happen? If you tried to travel between galaxies, imagine you could board a spacecraft and leave the Milky Way, heading toward Andromeda, our nearest galactic neighbor. You launch from Earth, accelerate to a significant fraction of light speed, and begin the crossing. What would you encounter? What would that journey be like? The answer is both simple and unsettling. Almost nothing. For millions of years, you would travel through darkness so complete, so empty, that it would redefine your understanding of loneliness. According to NASA's Jet Propulsion Laboratory, the fastest spacecraft humans have ever built is the Parker Solar Probe, which reached speeds of about 430,000 miles per hour, roughly 0.064% the speed of light. At that speed, traveling to Andromeda would take about 4 billion years, longer than complex life has existed on Earth, longer than our planet has been habitable. The sun would die before you arrived, Earth would be long gone, swallowed by the expanding sun, or ejected from the solar system by gravitational perturbations. But let's imagine a more advanced scenario. Suppose you could accelerate to 10% the speed of light, a velocity that might be achievable with theoretical technologies like antimatter engines or fusion drives. At this speed, the journey to Andromeda would take 25 million years. That's still incomprehensibly long, a timescale that dwarfs all of human history. Civilizations would rise and fall, species would evolve and go extinct, and you would be traveling through darkness. The space between galaxies, called the intergalactic medium, is not completely empty. According to observations by NASA's Chandra X-ray Observatory and ESA's XMM Newton satellite, it contains about 1 atom per cubic meter, mostly hydrogen. For comparison, the best laboratory vacuums on Earth contain millions of particles per cubic meter. Intergalactic space is emptier than anything we can create, a void so profound that you could travel for light years without encountering a single atom. There would be no stars to guide you. The Milky Way, once you left its gravitational influence, would shrink behind you, a spiral of light growing fainter with each passing million years. Ahead, Andromeda would remain a small distant smudge, barely distinguishable from the background glow of other galaxies scattered across the sky. For most of the journey, you would be too far from any galaxy to see individual stars. The universe would appear as it truly is, vast collections of light separated by incomprehensible darkness. The cosmic microwave background, the faint afterglow of the Big Bang, would surround you. This radiation, detected by ESA's Planck satellite and NASA's WMAP mission, fills all of space with photons cooled to just 2.7 degrees above absolute zero. It would be the only constant companion on your journey, a reminder that space, empty as it seems, still carries the echo of the universe's birth. But there would be dangers, subtle and strange. Cosmic rays, high-energy particles accelerated by supernova explosions and other violent events, permeate intergalactic space. According to NASA's Fermi Gamma Ray Space Telescope, some of these particles carry energies millions of times higher than anything we can produce on Earth. Without the protection of a planetary magnetic field or a galactic environment, your spacecraft would be constantly bombarded. Over millions of years, this radiation would degrade materials, damage electronics, and pose a lethal threat to any living crew. Then there's the problem of navigation. In intergalactic space, far from any massive objects, there are no landmarks, no reference points. GPS doesn't work because there are no satellites. Visual navigation is nearly impossible because galaxies are so distant and appear so small. You would need to rely on inertial guidance, measuring your velocity and trajectory with extreme precision, or on observations of distant quasars, the brightest objects in the universe, which can serve as cosmic beacons. And time would behave strangely. If you traveled at a significant fraction of light speed, relativistic effects would kick in. Time dilation, predicted by Einstein's special theory of relativity, means that time aboard your spacecraft would pass more slowly than time in the outside universe. At 10% light speed, the effect is small, but at 50% or higher, it becomes significant. A journey that takes 25 million years from the perspective of the Milky Way might feel shorter to you, perhaps only a few million years. But this is no comfort. Everyone and everything you left behind would still age normally, lost to time long before you arrived. The James Webb Space Telescope has captured images of distant galaxies, showing their structure, their spiral arms, their star-forming regions. But between those galaxies, in the deep black spaces of the images, lies nothing. No stars, no nebulae, no light. Just the faint glow of distant galaxies, pinpricks in an ocean of darkness. That darkness is what you would cross. A void so empty that it challenges the mind's ability to comprehend nothingness. Some physicists have speculated about traversing intergalactic space using wormholes, hypothetical tunnels through space-time that could connect distant regions. According to general relativity, wormholes might exist, but keeping them open would require exotic matter with negative energy, something never observed in nature. Even if wormholes were possible, creating one stable enough and large enough for a spacecraft would require technology far beyond anything we can imagine. Another idea is the Alcubierre drive, a theoretical propulsion system that warps space-time around a spacecraft, allowing it to move faster than light without violating relativity. The concept, proposed by physicist Miguel Alcubierre in 1994, remains purely speculative. It would require vast amounts of negative energy and would likely be unstable. But even if it worked, the distances between galaxies are so vast that the journey would still take years or decades, a significant undertaking for any civilization. As astrophysicist Neil deGrasse Tyson has said, "The universe is under no obligation to make sense to you. The distances between galaxies are not designed to be crossed. They are barriers enforced by the structure of space-time itself, reminding us that galaxies are islands, isolated in a sea of darkness that grows ever wider." Take a quiet breath. If you left Earth today, traveling at 10% the speed of light, you would spend 25 million years crossing the void between galaxies. For most of that time, you would see nothing but distant pinpricks of light, surrounded by darkness so absolute it would redefine emptiness. The isolation would be total, the journey incomprehensible, the destination so far away that arrival would feel like a myth. And as we contemplate this impossible journey, another question arises. If galaxies are so far apart, does that mean we're alone? What are the chances that life exists in other galaxies? And if it does, will we ever know? That's where our next chapter takes us. Part 3. Are we alone across the cosmic void? The distances between galaxies create a kind of cosmic quarantine. Even if intelligent life thrives in Andromeda, even if civilizations millions of years older than ours have built technologies we can't imagine, we would never know. The gulf between us is too vast, the barriers too absolute. Light takes 2.5 million years to cross that distance. A signal sent from Andromeda today would not reach Earth until long after human civilization has transformed or disappeared. And a reply would take another 2.5 million years to return. This is not conversation. This is shouting into a void and hoping an echo returns millennia after you've forgotten the message. According to the Drake equation, formulated by astronomer Frank Drake in 1961, the number of detectable civilizations in our galaxy depends on factors like the rate of star formation, the fraction of stars with planets, and the likelihood of life developing intelligence. Even optimistic estimates suggest that advanced civilizations might be rare, scattered across the Milky Way, with thousands or tens of thousands of light years between them. But at least within a galaxy, communication is theoretically possible. Signals could cross the galaxy in tens of thousands of years, a long time by human standards, but manageable on cosmic timescales. Between galaxies, the situation is fundamentally different. NASA's Kepler Space Telescope and TESS mission have discovered thousands of exoplanets within our galaxy, many in the habitable zones of their stars. These discoveries suggest that planets are common, and by extension, life might be too. But those are planets in our galaxy. Planets in Andromeda, though they almost certainly exist, are forever beyond our reach. We can never visit them, never send probes, never receive signals, because the distances and timescales involved exceed anything our species or our technology can handle. ESA's Gaia mission has mapped over 1 billion stars in the Milky Way, revealing the structure and dynamics of our galactic home. But it has told us nothing about other galaxies, nothing about the worlds that might orbit stars in Andromeda or Triangulum. Those galaxies are too far away for detailed study. We can measure their overall properties, their mass, their rotation, their chemical composition. But individual stars, individual planets, they're invisible, too faint and too distant to detect. This creates a strange kind of solitude. If intelligent life exists in other galaxies, and the sheer number of galaxies suggests it probably does, then the universe might be teeming with civilizations, but they're all isolated, separated by voids so vast that contact is impossible. Each galaxy is its own island, its own ecosystem, cut off from the others by distances that make even light seem slow. Some scientists have speculated about intergalactic civilizations, advanced species that might have found ways to bridge the gaps between galaxies. Physicist Freeman Dyson proposed the idea of Dyson spheres, megastructures that could harness the energy of entire stars. A civilization capable of building such structures might also be capable of intergalactic travel, perhaps using generation ships that travel for millions of years, carrying multiple generations of inhabitants who live and die en route. But even for such advanced civilizations, the distances remain daunting. According to calculations by NASA's Jet Propulsion Laboratory, a spacecraft traveling at 10% the speed of light would require enormous amounts of energy, equivalent to the entire energy output of a large nation for many years, just to accelerate to that speed. Sustaining a crew for millions of years would require life support systems far beyond our current capabilities, along with solutions to problems we barely understand, like the psychological effects of isolation, the genetic drift in small populations, and the maintenance of technology over timescales longer than recorded history. And there's another problem. The expansion of space means that galaxies are moving apart. Andromeda, fortunately, is gravitationally bound to the Milky Way, and the two galaxies are actually approaching each other. In about 4.5 billion years, according to simulations by NASA's Goddard Space Flight Center, they will collide and merge, forming a new elliptical galaxy. But most galaxies are receding. The farther away they are, the faster they move. Galaxies beyond a certain distance are receding faster than light can travel, making them not just unreachable, but causally disconnected. We can never influence them, and they can never influence us. This paints a picture of a universe that is fundamentally lonely. The Fermi paradox, proposed by physicist Enrico Fermi, asks, if intelligent life is common, where is everybody? One answer might be that they're out there, thriving in other galaxies, but the distances are so vast that contact is impossible. Each civilization is confined to its own galaxy, isolated by the structure of space-time itself. The search for extraterrestrial intelligence, SETI, has been scanning the skies for decades, listening for radio signals from other civilizations. But SETI focuses on our galaxy. The chances of detecting a signal from another galaxy are vanishingly small. Even if a civilization in Andromeda were broadcasting with the power of an entire star, the signal would be so faint by the time it reached us that it would be indistinguishable from background noise. The James Webb Space Telescope is studying the atmospheres of exoplanets within our galaxy, searching for biosignatures, signs of life like oxygen or methane. But these studies are limited to nearby stars, within a few hundred light years. Planets in other galaxies are completely beyond reach, invisible to even our most powerful instruments. As Carl Sagan once said, "The cosmos is within us. We are made of star stuff." But the cosmos is also beyond us, spread across distances so vast that most of it is forever inaccessible. If life exists in other galaxies, and it probably does, then the universe is filled with islands of consciousness, each one alone, separated by voids that cannot be crossed. Take a slow breath. Somewhere in Andromeda, there might be a world like Earth, with oceans and continents, clouds and storms. There might be beings looking up at their sky, wondering if they're alone, just as we do. But we will never know. The distance between us is too great, the barrier too absolute. We are neighbors in the cosmic sense, separated by a mere 2.5 million light years. But that nearness is an illusion. We are alone, each galaxy a solitary island in an expanding ocean of darkness. And as we sit with this isolation, a final question emerges. If the distances between galaxies are so vast, what does this mean for the future? Will the universe become even emptier? The distances even greater? That's where we drift next. Part 4. The universe is getting lonelier. The distances between galaxies are not static, they're growing. Every moment, the fabric of space expands, stretching the voids, pushing galaxies farther apart. This expansion, driven by dark energy, means that the universe is becoming increasingly empty, increasingly isolated, and the process is accelerating. In 1998, two teams of astronomers studying distant supernovae made a shocking discovery. The universe's expansion was not slowing down as most scientists expected, but speeding up. This finding, which earned Saul Perlmutter, Adam Rees, and Brian Schmidt the 2011 Nobel Prize in Physics, revealed the existence of dark energy, a mysterious force that makes up about 68% of the universe's total energy. According to ESA's Planck satellite and NASA's Dark Energy Survey, dark energy behaves like a cosmological constant, a property of space itself that pushes outward, counteracting the inward pull of gravity. The more space there is, the stronger the push, creating a runaway effect. As the universe expands, more dark energy appears, driving even faster expansion. This means that the distances between galaxies, already incomprehensibly vast, are growing exponentially. Galaxies that are currently billions of light years away are receding at speeds approaching light speed. In time, they will slip beyond our cosmic horizon, their light stretched to infinite wavelengths, rendering them invisible. Future observers, billions of years from now, will see a much emptier sky than we do. The local group, our small cluster of galaxies including the Milky Way, Andromeda, and about 80 smaller galaxies, is gravitationally bound. These galaxies are close enough that their mutual gravity overpowers the expansion of space. Over the next several billion years, according to simulations by NASA's Goddard Space Flight Center, the galaxies in the local group will merge, eventually forming a single massive elliptical galaxy. But beyond the local group, everything is moving away. The Virgo cluster, 65 million light years away, is receding at about 1/200 kilometers per second. The Coma cluster, 320 million light years away, is receding at about 7,000 kilometers per second. Galaxies a billion light years away are receding at about 21,000 kilometers per second, roughly 7% the speed of light. And galaxies at the edge of the observable universe are receding faster than light can travel, not because they're moving through space, but because space itself is expanding so rapidly. What does this mean for the future? As physicist Lawrence Krauss describes in his book, A Universe from Nothing, the universe is heading toward a state of maximum isolation. Billions of years from now, the local group will have merged into a single galaxy, and all other galaxies will have disappeared beyond the cosmic horizon. Observers in that distant future will look up at a sky devoid of distant galaxies, unaware that a vast universe once surrounded them. They might conclude that their galaxy is the entire universe, a lonely island in an infinite void. This process is called the Big Freeze, or heat death of the universe. According to ESA's Euclid mission, the acceleration of expansion means that eventually all matter will be spread so thin, all galaxies so far apart, that the universe will become cold, dark, and empty. Stars will burn out, black holes will evaporate, and the distance between any two remaining objects will be so vast that they can never interact, never influence each other, never even be observed. The James Webb Space Telescope has captured images of distant galaxies as they appeared billions of years ago when the universe was younger and denser. These galaxies are closer together, their light not as redshifted. But those are views of the past. In the present, those same galaxies are much farther away, and in the future, they will be unreachable, their light stretched beyond detection. Some cosmologists, including Roger Penrose, have proposed alternative scenarios. Perhaps the universe will eventually stop expanding and begin contracting, leading to a big crunch. Or perhaps dark energy will change over time, weakening or even reversing. But current observations suggest that dark energy is constant, relentless, and permanent. The universe will continue expanding forever, becoming colder, darker, and lonelier. NASA's upcoming Nancy Grace Roman Space Telescope will study dark energy in unprecedented detail, measuring how the expansion rate has changed over cosmic time. If dark energy is strengthening, the isolation could happen faster. If it's weakening, the universe might stabilize. But either way, the trend is clear. The distances between galaxies are growing, and they will continue to grow. This creates a profound sense of impermanence. The universe we observe today, filled with billions of galaxies, each containing billions of stars, is temporary. It's a brief moment in cosmic history when matter is dense enough to form structures, close enough to be observed. In the far future, that moment will have passed. The universe will return to a state of near emptiness, with isolated galaxies separated by voids so vast that light from one can never reach another. As cosmologist Brian Greene has said, the universe is not only stranger than we imagine, it is stranger than we can imagine. The distances between galaxies, already incomprehensible, are just the beginning. The future holds even greater isolation, even vaster voids, a cosmos where nearness is a fleeting illusion and separation is the eternal truth. Take a long, slow breath. Right now, at this very moment, the galaxy nearest to us is drifting away. Not Andromeda, which is approaching, but nearly every other galaxy in the universe. They're receding, carried by the expansion of space, and the rate of that recession is increasing. Every second, the distances grow. Every moment, the universe becomes a little emptier, a little lonelier, a little more isolated. And as we contemplate this expanding loneliness, a final question emerges. What does it mean for us here and now to live in a universe of such vast and growing distances? How should we think about our place in this cosmic emptiness? That's where our last chapter takes us. Part 5. What it means to live on a cosmic island. We live on a planet orbiting a star in a galaxy containing hundreds of billions of other stars. But that galaxy, vast as it is just a tiny island in an ocean of emptiness. The nearest major island, Andromeda, lies 2.5 million light-years away, separated from us by a void so vast that crossing it would take longer than our species has existed. Beyond Andromeda, the distances grow even more staggering, the voids even more profound. We are, in the truest sense, alone. This isolation is not temporary, it's fundamental. The structure of space-time, the expansion of the universe, the vast distances between galaxies, all conspire to keep us confined to our cosmic island. We can observe other galaxies, study their light, measure their properties, but we can never visit them, never communicate with them in any meaningful way, never escape the boundaries of our local neighborhood. For some, this realization is terrifying. Philosopher Blaise Pascal famously wrote, "The eternal silence of these infinite spaces frightens me. The universe's vastness, its emptiness, its indifference to human existence can feel overwhelming. We are tiny, insignificant, confined to a single planet in a single galaxy, separated from everything else by distances that mock our ambitions." But there's another way to see it. According to Carl Sagan, The fact that we can ask these questions, that we can measure the distances between galaxies, that we can understand the structure of the universe, is itself remarkable. We are a way for the cosmos to know itself, he said. Our isolation doesn't diminish this achievement. If anything, it amplifies it. Within our galaxy, the Milky Way, there are hundreds of billions of stars. NASA's Kepler Space Telescope and TESS mission have discovered thousands of exoplanets, many in the habitable zones of their stars. Some of these worlds might harbor life, some might even harbor intelligent civilizations. The distances between stars within a galaxy are vast, but they're manageable on cosmic timescales. Signals could cross the galaxy in tens of thousands of years. Travel, though difficult, is not fundamentally impossible. So while we may be isolated from other galaxies, we are not alone within our own. The Milky Way is our home, our ecosystem, our community. It contains more stars than we can count, more worlds than we can explore, more possibilities than we can imagine. The fact that Andromeda is unreachable doesn't make our galaxy any less vast or any less full of wonder. The James Webb Space Telescope exemplifies this perspective. By studying the atmospheres of exoplanets within our galaxy, by capturing the light of distant stars and nebulae, by revealing the structure and beauty of our cosmic home, JWST reminds us that there is more than enough within our reach to fill 1,000 lifetimes of exploration. We don't need to cross intergalactic voids to find wonder. It surrounds us here and now within the boundaries of the Milky Way. ESA's Gaia mission has mapped over 1 billion stars, revealing the intricate dance of our galaxy, the way stars orbit the galactic center, the way they cluster into groups, the way they form and die. This map is our cosmic address book, showing us not isolation, but connection, not emptiness, but structure, not loneliness, but community. And there's something else. The distances between galaxies, vast as they are, also give us perspective. When we look at Andromeda, we're seeing light that left that galaxy 2.5 million years ago. We're looking back in time, witnessing the past. The universe, in this sense, is a time machine, allowing us to observe history, to trace the evolution of stars and galaxies, to see how the cosmos has changed over billions of years. The cosmic microwave background, the faint afterglow of the Big Bang detected by ESA's Planck satellite, shows us the universe as it was just 380,000 years after its birth. The most distant galaxies captured by JWST show us cosmic structure as it appeared when the universe was young. These observations tell a story, a narrative of creation and evolution, of matter cooling and condensing, of stars igniting and galaxies forming. The distances, the time delays, they don't obscure this story. They reveal it. Physicist Richard Feynman once said, "I would rather have questions that can't be answered than answers that can't be questioned." The distances between galaxies give us questions, profound and humbling. How did the universe come to be so empty? Why does dark energy push galaxies apart? What does it mean to live in an expanding cosmos? These questions don't have easy answers, but they inspire wonder, curiosity, and a sense of connection to something larger than ourselves. In the far future, billions of years from now, the Milky Way and Andromeda will merge. Simulations by NASA's Goddard Space Flight Center show that this collision, though violent on cosmic scales, will likely not destroy any stars. The distances between stars within galaxies are so vast that direct collisions are rare. Instead, the two galaxies will pass through each other, their gravity pulling them back together, creating a new larger galaxy. Humans, if we still exist, will witness this transformation. The night sky will change, filled with new constellations, new nebulae, new wonders. But beyond our merged galaxy, the universe will be emptier. The distances to other galaxies will have grown. Many will have slipped beyond the cosmic horizon, their light too stretched, too faint to detect. Future civilizations will live in a lonelier cosmos, isolated in ways we can barely imagine. Yet, even in that future, even in that loneliness, there will be wonder. The merged galaxy will contain trillions of stars, countless worlds, endless possibilities. The isolation from other galaxies might be absolute, but the richness within will be immense. So what does it mean to live on a cosmic island? It means recognizing both our smallness and our significance. We are small, confined to a single galaxy in a vast universe. But we are also significant because we can understand, we can question, we can explore. The distances between galaxies are terrible, yes, but they're also beautiful. A reminder that the universe is larger, stranger, and more wondrous than we often remember. Take one last slow breath. You are here on a planet orbiting a star in a galaxy containing hundreds of billions of other stars. Around you, separated by incomprehensible voids, are billions of other galaxies, each one an island like ours. You will never visit them. No one will. The distances are too vast, the barriers too absolute. But you can see them, you can study them, you can wonder at them. And in that wondering, you connect to the cosmos, not through proximity, but through understanding. The distance between galaxies is far worse than you think, but it's also far more beautiful, far more profound than simple nearness could ever be. Conclusion: islands in an infinite sea, so we return to where we began. The distances between galaxies are not just large, they're incomprehensibly vast. Stretches of emptiness so profound, they challenge our ability to conceive of distance at all. Andromeda, our nearest galactic neighbor, lies 2.5 million light-years away. Most galaxies are billions of light-years distant, separated by voids containing almost nothing, growing farther apart with each passing moment. We live on a cosmic island, confined to the Milky Way by the structure of space-time itself. We can observe other galaxies, measure their properties, trace their light across billions of years. But we can never visit them, never communicate with them, never escape the boundaries of our local neighborhood. The universe, for all its vastness, is fundamentally lonely. Yet, within our galaxy, there is wonder enough to fill eternity. Hundreds of billions of stars, countless worlds, endless possibilities. The fact that Andromeda is unreachable doesn't diminish the Milky Way. It doesn't make our cosmic home any less vast, any less beautiful, any less full of mystery. The distances between galaxies remind us of our place in the cosmos. We are small, temporary, isolated, but we are also conscious, curious, capable of asking questions that stretch across the universe. And in that capability, we find meaning, connection, and a kind of cosmic belonging that transcends mere proximity. As you drift off tonight, remember this: you live on a cosmic island surrounded by an ocean of emptiness. The distances to other islands are so vast that light takes millions of years to cross them. Most of the universe is forever beyond your reach, hidden by barriers of time and space you can never overcome. But here, on this island, within the Milky Way, there is more than enough to explore, more than enough to wonder at, more than enough to remind you that you are part of something vast, ancient, and endlessly strange. If this quiet journey has brought you even a small moment of peace, I'm deeply grateful you've spent it here with me. A gentle like or a soft tap on subscribe means more than you can imagine. It's what keeps me creating these cosmic lullabies for wandering minds like yours. And if you're kind enough, please tell me in the comments where you are tonight and what time it is where you're listening. I love seeing how far these quiet adventures drift across the world, from one sleepy corner of the planet to another. Your words, your presence, even your silence, they're like little stars guiding me forward, and I treasure them deeply. Until next time, may the vastness of space remind you of both your smallness and your significance. May the distances between galaxies inspire wonder rather than fear. And may you find comfort in knowing that here, on our cosmic island, you are home.